Oh, thank you. I don't know what is the time limit that I have, but I'll try to be short. Although it might be a little bit boring because at the beginning there was stuff that we kind of encountered in the previous sessions, but I'll try to be short. So the aim of this paper by Hartmann and Sprenger, they try to illustrate some sort of a compatibility between how traditional epistemology and Bayesian epistemology could be compatible with each other, not replacing one another. So he tries to first try to introduce the Bayesian probabilistic calculus, and then he tries to illustrate some evidence measures that we have based on the Bayesian reasoning, Bayesian logic, and then we tried to go and see some models of coherence and testimony, and then to conclude the paper by saying that how these two, Bayesian epistemology and traditional epistemology, are compatible. So the initial idea is that they say that the way how we approach deductive logic as being the logic of for rational belief, you can also have a logic of partial belief, which can be regarded as which could be Bayesianism could be a representation of that logic, and this comes in the forms of degrees of belief. So degrees of belief, if we give an example of degrees of belief, say in a triplet of A, X, and Y, if A is the outcome and X are and X and Y are the amount paid dependent on the outcome A, whether if it's for the booker or the better, then a mathematically formula that could try to describe our degree of belief would be as X plus Y over X. And in a fair non-advantageous game, this criteria holds, which is the idea that probability of Y minus 1 minus probability of X must equal to 0, which also says that our degrees of belief must be in between the limits of 1 and 0. And then he goes on to try to illustrate the three main axioms of degrees of probability in Bayesianism, which is these three axioms: a tautology of A must be PA would be equal to 1. If we have two incompatibles, basically A and B, then A or B must be equal to A. Probability of A or B must be equal to probability of A plus probability of B, and from this axiom we could also obtain probability of A or the negation of A must be equal to probability of A plus negation of A must equal to 1. And then he goes on to talk about the Dashbook theorem, and that is any betting odds which one of these three axioms is violated could be considered as a Dashbook theorem, and a risk-free gain is the short. So, and then he goes on to try to illustrate what we consider to be as a converse Dashbook theorem, which is the idea that the probability function of P, the probability function of A, if it's between 0 and 1, is vulnerable to a Dashbook. No probability function where the proposition we have is between 0 and 1 is vulnerable to a Dashbook. And then he goes on to say, like in cases where the subjective degrees of belief and objective chances seems to be inconsistent, then we have a principle, which is called the principle, saying that if an agent knows the objective probability of proposition A to be equal to P, and he has no overruling information available, then it's his rational degree of belief in A must also be equal to P. So this gives us an account of how degrees of belief change with new information. So basically, this is like saying if we have no overruling information that could be considered in changing our degrees of belief about a certain fact, then it's rational to believe in that certain fact because we have any overruling information that could convince us otherwise. So apart from the Dutch book and the principle, there is the other question of Bayesian conditionalization, which is the idea of how the dynamics of Bayesianism work. And that could be illustrated in the following equation, which the probability of H, the new H or the new hypothesis would be equal to the probability of the hypothesis given the evidence, and would be equal to probability of hypothesis prior than probability of evidence given the hypothesis over the probability of evidence. And this rule could be also like he tries to illustrate this of how this works with an example, saying that if a friend buys a Ford, then the probability of one of his friends buying a Ford, it's 0.1, and he owns a Ford. Then if he saw his friend coming with a Ford, then the probability of that, the evidence, we have enough evidence to believe, since he is not using his wife's Toyota, we could give a probability of 0.8, and we could also say that if he doesn't own a Ford, he would have he wouldn't have come with a Ford anyway. So the probability of E given minus H must, if we say it's equal to 0.5, then the new probability saying that he has bought a Ford would be 0.94. Okay, so then we go to talk about, he goes on to talk about measuring evidence. So how could traditional epistemology help us within probabilistic epistemology? And this is like the idea that how, like, he talks about 3 or 4 different measuring evidences, and how these, like Bayesian epistemology, how traditional epistemology comes in contact with Bayesian or probabilistic epistemology. So he talks about, in the beginning, he talks about 2 different sort of evidences. One of them is an absolute evidence, which is the idea that E is an absolute evidence for proposition A if and only if the probability of A given E is high. But then he goes on to say that this account would sometimes be problematic, because sometimes E can be an evidence even if it lowers the probability value of the prior probability value. Like in the case where he brings up the example that if A is your club, the idea that your club will not win the championship this year, and the evidence being that they won the first match, intuitively, them winning the first match must be a counter evidence for them winning the championship this year, not confirming evidence. So this concludes that E can sometimes lower the probability value counter to what we have in the absolute evidence approach. The second idea, the second approach to evidence is the relative evidence, which is the idea that E could be counted as a relative evidence for A if the probability of A given E is higher than the probability of A itself, isolated from A. So later on, he goes to talk about for measuring evidences. Basically, these are the ways which we could, with them we could measure our evidence: the difference measure, the log ratio measure, counterfactual difference measure, and the low likelihood measure. So depending on like each one of them would, there's a form or there's a sort of equation which tries to illustrate how they measure the evidence. So for example, the difference measure would, the degree of the evidence would be dependent on the idea that whatever value the difference of the posterior and prior degree of belief leads in would be equal to the degree of evidence that we have. And another one would use a log ratio, and the other one would use a counterfactual difference measure. And each of them, as illustrated in the book, they are given different symbols. So the difference measure would be the small d, the log ratio measure would be the r. So after he tries to illustrate these different measures, he goes on to bring about measure sensitive problems to say that these these evidence measurers, they would fall into some sort of trouble given different sorts of problems. So basically concluding that there's no measuring evidence device which could basically account for all of the evidence, but in one of the instances he tries to bring about he tries to talk about the surprising evidence, which is the idea that if everything is if all the things are equal, each evidence measure should render the force of surprising evidence. So basically, if we have two sort of probabilities, probability of E given A and probability of E prime given A, and if the probability of E is let, sorry, I don't know whether my connection is, can you hear me?
Yes,
oh, okay. So, and if the probability of E is less than the probability of E prime and both, okay, and E prime are evidences for A, then according to the surprising evidence measure, E must, and for all evidence measures, E must be a better evidence for A rather than E prime because of the surprising evidence. So this can satisfy all the measures that we talked about before, and then he goes on to talk about the independence measure, saying that if E1 and E2 are evidences for A, and if A screens off E1 from E2, and these two are independent from each other, so the evidence measure of A given E1 and E2 must be higher than the measure of A given only E1. But as he tries to illustrate the difference measures that we talked about, S would be a violation of this principle. So he goes on to say this would not satisfy S. Then he goes on to talk about a relevant conjunction, which is the idea that E is evidence for A, and the probability of E given A and X must be is equal to probability of E given A for a sentence X consistent with A. So this would come in the form of something like the probability, like the evidence saying that like it's 2 o'clock, then this can count as an evidence for the start of philosophy class. But then this also can count as an evidence.
I cannot hear you anymore.
For the starting of the philosophy.
It's fine, I think.
Wait. Now it's fine?
Yes.
Okay. Sorry, I'm just having some, lately I've been having some connection troubles. Anyway, so the idea of a relevant conjunction is that for the evidence that we have, if it's 2 o'clock, then it would basically lead to me having a philosophy class, and the evidence that 2 o'clock would count also for me having a philosophy class and me winning the championship. Generally, these two probabilities must be equal, since X is consistent with A. So here, but intuitively, we know that we need an evidence measure in which in it the evidence measure in which in it A and E must be equal to A and X with E. So basically, we are sure that we need an evidence measure that counts for the philosophy class, the evidence being related to the philosophy class only, not with the philosophy class and my club winning the championship. Basically, he tries to bring up with a principle that saying that so if you assume E is evidence for A and P and giving the prior condition of E, A and X equal to probability of E given A, for the proposition of X, which the probability of X giving A and K must not be equal to 1, then given this condition, the probability of A and X decreases. Therefore, the evidence would entail that P is the probability of E given A must be higher than the probability of A given A and X. So basically this is a condition based on the prior assumption that we talked about, and this is true for D, L, and S, but not for R. So in this example, he tries to illustrate how this is also R can also be eliminated here. And the last two measures that remains, which are D and L, he says they are opposite to each other. D would be an internalist increase in credibility from probability A to probability of A given E, while L captures an internalist discriminative power of the evidence with respect to the proposition in question. And last, he tries to talk about another fallacy, which is the conjunction fallacy. It's basically the same as the prior thing that we talked about, but in this instance, he gives an example of Linda, the feminist bank teller, in which saying that we have an evidence, Linda being a girl who is like, who stands up for things, and like she is involved in a lot of protests for people that they have their rights and stuff like that. So we have two assumptions. One of them is Linda is a bank teller, and the other one is A and X, which is Linda is a bank teller and a feminist. So given the prior evidence, we know that we know that E must is an evidence for X. So in this scenario, we have to choose the probability of the evidence given A and X must be higher than the probability of evidence given A. But this can also cause us a problem to the above mentioned rule, in which we say the probability of E given A and X is equal to the probability of E given A, which is the condition we talked about before, that for Bayesian reasoning, this holds true, but this is counterintuitive according to the conjunction fallacy. So in conclusion for this section, he basically says the Bayesian techniques are valuable means to tackle traditional epistemological problems, but also traditional epistemology is a guiding principle of choice between evidence measures. Later on, he talks about coherence and testimony. And he talks about, it's true that we say a set of proposition is justified if it coheres well, but what do we mean by cohere? So he brings about two coherent intuitions. One of them is, he calls it R, which is coherence as positive relevance, which is the idea that coherence sets mutually support one another or support each other. So if we have a set where its propositions are positively relevant to one another, they are more coherent than independent propositions, or a set with a negatively relevant propositions. And then he talks about the other intuition, which is O, coherence as an overlapping probability space, which is the idea that identical propositions are considered to be coherent. Like, for example, if some people have identical reports about a crime scenario, then the coherency would increase, but any deviation would decrease the coherency. So based on this, he talks about some coherence measures, which can be that has been formalized. One of them is the Schrödinger measure, which is the idea of the Schrödinger measure is only based on pure relevance measure, the R measure or the R intuition, which is the idea that how the probability of A is raised given that B is true that satisfies this rule, which is the measure of coherency of A and B is equal to probability of A given B over A, and the equation goes on. The other formalized measure would be the Glass-Olsen measure, which this one is a purely overlap measure, which is the idea that basically coherency is only based on overlaps and the overlap intuition, and it's formalized in the following equation. Then he later on goes on to talk about another measure, which is the Bovins-Hartmann measure. This measure considers both relevance and also overlap as guiding principles and for the measure, but it doesn't start with formalization of the epistemic intuition, but rather it starts with a question of what the coherence of a set of proposition is. And the answer to the coherence of a set of propositions he gives about is that it boosts our confidence in truth of these propositions. And the way he formalizes is something like this. So if we have a set of propositions composed of propositions A1 until AN, and for each A1 we have another set which is basically EI, which is the amount of evidences we have compared to like from each number of witness that we have. So each A1 must have an E1, something like that. So each proposition have an evidence. So the coherence measure must have, then according to this set of propositions, the coherence measure must have these three, must satisfy these three conditions. The first one being that the measure of posterior probability and prior probability, we have to find them out according to those rules, and then the ratio between them must be, we must find out the ratio between them, which is the, So, and then we have the normalizing ratio to ensure that the propositions fully overlap with the probability space of maximal coherence. So this, the first one is taking the relevance intuition into account, and the second one is taking the overlap intuition into account. And then lastly, he talks about solving a problem of traditional coherence, which is the idea that coherence is the measure of the intrinsic property of the sets of propositions, regardless of reliability of the witnesses. So in this case, he says that if we have a set N being more coherent than set S prime N, it is more coherent than that if the normalized ratio of the posterior and prior probabilities of Sn is greater than that of S prime N for all values of the reliability of the witnesses. So basically, if we have two sets, both of them satisfying the first two conditions, then the one coherent would be the one that after satisfying these two conditions would have a more coherent value, giving all the reliability of the witnesses, satisfying the prior two conditions. So, and then he, later on, he tries to have, he goes to his conclusion about coherence measures. And he says that none of the coherence measures proposed so far is without problems, and they have all been confronted with counterexamples. Sometimes, however, different authors have different intuitions. So this is one issue, whether the intuitions given the beginning are like objective intuitions. So different authors have different intuitions, and no agreement is reached as to whether a certain measure is defective or not. So in conclusion, he says there's no measure which reflects our intuitions about coherence. So a plurality of coherence measures should be taken. And also that his proposal is that we take an empirical approach to study coherence on people, then to use it to confront the coherence measures within the philosophical literature. That would be one of his proposals. And so he basically tries to conclude it this way, that he hopes a combination of empirical studies, formal modeling, and conceptual analysis can help us in resolving the current debate about the coherence measures. Coherence and truth. So he basically tries to answer this two questions about his view of coherence and truth. The first one being that what is the effect of coherence on a set of propositions on the posterior probability? And the answer is, his answer is, the more independent the witnesses are, the impact of the coherence is greater. So he's basically trying to say that the independency can lead us to a greater impact of coherence. And then he's trying to say under which conditions is coherence truth conductive. And he says that he brings two impossibility theorems that show that there's no coherent measure that fulfill any, like a given number of plausible requirements. And one of the people that propose the impossibility theorems concludes that there's no indicator of truth, coherence is no indicator of truth. And the other one is saying that negative results of their impossibility theorem can be avoided by not always ordering a set of propositions according to coherence. But he also says that, however, there are certain cases in which coherence can be an indicator of truth, but like, as he tries to illustrate it, it's very restrictive cases. So like when two sets of propositions have equal cardinality and the same prior probability, the one with the higher posterior probability is more coherent, given that all witnesses have the same reliability. So this is a very restrictive case in which coherence can be an indicator of truth. And then he goes on to say, then therefore we need more realistic models of information gathering, and coherence consideration in belief revisions needs to be considered in more detail. Only to finish conclude his paper by saying that Bayesian epistemology has the resources to make testimony questions more precise and answer them given prior evidence. Traditional epistemology and Bayesian epistemology can learn from each other, the former inspiring the later, as we've seen throughout the paper, and also the latter making the former more precise. But he also suggests that they both need to profit from empirical data.